Have you ever just stopped and wondered why the universe follows the specific laws it does? Like, why is energy conserved? Or why does quantum mechanics use complex numbers instead of, well, literally any other type of math? Usually, trying to answer these massive mysteries means you just have to accept that the fundamental laws of physics are just arbitrary rules, handed down from nowhere. But what if they're not arbitrary at all? What if they are actually the inevitable consequence of a single, inescapable logical premise? Welcome to our explainer. Today we're diving into a genuinely fascinating framework that suggests we don't actually need to invent physical laws. We just need to follow one simple rule to its absolute limit. So today we're going to try to derive the foundations of reality itself from one undeniable axiom. An axiom that essentially forces the universe into the shape we observe every day. It all boils down to this one question. What if physics is just what independence looks like from the inside? We're going to explore how this simple, intuitive idea that independent things must remain independent acts as a sort of structural spine. And as you'll see, this spine dictates local conservation, it absolutely mandates complex numbers in quantum mechanics, and it even forces the internal symmetries of particle physics. To get there, here's our roadmap for this explainer. First, we'll define this cosmic rule and then translate it into the math of commutivity. From there, we'll explore the three layers of the independent spine. Layer 1 covers local conservation. Layer 2 dives into eliminating quaternions to find reality's unique scalar field. And Layer 3 explores gauge symmetries. Finally, we'll bring the whole thing together in the three-layer identity. Okay, let's jump right into Section 1, the cosmic rule, setting the ultimate foundation of reality. All right, let's unpack this. The core rule here is called C1a, or independence preservation. It formally states that independent distinctions remain independently continuable. So what does that mean in plain English? Think of two people walking down completely separate streets, right? If they are truly independent, the path person A takes absolutely cannot suddenly be blocked by a random choice person B makes. If system A and system B are doing their own things completely independently, the future evolution of A cannot secretly depend on B. I know, it sounds like really basic philosophy, but the mathematical consequences of this are about to blow your mind. Moving right along to Section 2, the math of commutativity, translating logic into the cosmic ledger. So what does independence actually look like as algebra? Well, if you have a joint transition of two independent systems, you can mathematically factor it into system A updating and system B updating. But here is the massive catch. For them to be truly independent, the order of operations absolutely cannot matter. If applying A, then B, gives you a different result than applying B, then A, well, that joint outcome relies on a secret ordering structure, and that hidden dependency completely violates our rule. Physicists write this strict requirement as the commutator of A and B equaling 0, or TA times TB equals TB times TA. This single equation, the vanishing commutator, is the structural spine of literally everything we are about to discuss today. Which brings us to Section 3, Layer 1, Local Conservation. Basically, why matter can't teleport. Picture this. Imagine a hypothetical violation of conservation. Let's say a transformation creates some net content over at location A, and a completely independent transformation destroys that exact amount of content at location B, just to keep the universe balanced. Okay, but how does B know exactly how much to destroy, and exactly when to do it? It would require a secret communication channel. The output of B would somehow have to depend on the output of A. But as we just established, coordinating independent continuations is a direct violation of the C1a rule. Because of that, net content cannot be borrowed from independent regions. The universe is mathematically forced to enforce strict local conservation. You just can't balance the books globally. Things have to move locally, step by step. All right, Section 4, Layer 2, eliminating quaternions, the intellectual climax of the scalar field. Now, to build quantum amplitudes, the source material turns to a really famous mathematical result called the Frobenius theorem. It basically tells us there are only three finite-dimensional division algebras over the real numbers that we could even possibly use: real numbers, complex numbers, and quaternions. We can actually rule out real numbers right away because a primitive constraint called C5 requires every observable event to simultaneously carry two independent degrees of freedom, one for propagation and one for residue. Real numbers only have one dimension, so they fail instantly. Which sets the stage for a cosmic showdown. Complex numbers, with two dimensions, going head-to-head against quaternions, which have four.
Now watch closely what happens when the universe tries to use quaternions as the scalar algebra for independent amplitudes. Quaternions have multiple imaginary units. Let's just call them I and j for now. If we apply an independent phase update using I and then another one using j, what happens? Well, in quaternion math, multiplying I then j equals k, but multiplying j then I equals negative k. They don't commute. The final outcome depends entirely on who went first. If the universe tried to use quaternions to encode independent phase updates, applying those updates would cause an illegal crash. The joint amplitude evolution would suddenly depend on this arbitrary ordering of independent operations.
Because this non-commutative VIDI introduces a secret ordering dependency, it completely violates our foundational rule that independent operations must commute. The commutator just does not equal 0. Therefore, quaternions are mathematically executed by the framework. They are entirely inadmissible. Complex numbers, on the other hand, they perfectly commute. Multiplying complex number a by b is the exact same as b times a, and that leaves complex numbers as the universe's unique, inevitable choice for quantum mechanics. The universe didn't just happen to randomly pick complex numbers, it is mathematically forced to use them.
On to Section 5, Layer 3, Gauge Symmetries, forcing the structure of the standard model. So, we take that exact same independence rule and apply it to the internal symmetry sectors of particles. If you have independent internal symmetry sectors, their generators, which are just the mathematical operators that define them, must also commute. If they didn't commute, a transformation in one sector would actually alter the state in a way that secretly depends on a transformation in another. And that perfectly mimics the kind of hidden entanglement we've been outlawing this entire time. Because of this, the independence rule literally forces the gauge sectors to factorize. Since the sectors must commute, the total symmetry structure can't just be one giant entangled mess. It has to split cleanly into a direct product of independent groups. And incredibly, this requirement perfectly echoes the precise architecture of the standard model of particle physics, which is famously a product of 3 groups: U1 for electromagnetism, SU2 for the weak force, and SU3 for the strong force. That specific structure isn't an accident. It's the direct shadow of independence.
Which brings us to Section 6, the 3-layer identity. 1 universal axiom, 3 foundational realities.
So let's pull back and look at the big picture here. 1 single rule, the absolute refusal to let independent things rely on a secret handshake, cascades across 3 distinct layers of reality. In the domain of dynamics, it prevents synchronization, which gives us local conservation. In the domain of scalar amplitudes, it prevents ordering dependence, eliminating quaternions and forcing the complex field. And in the domain of symmetry, it forces internal sectors to commute, giving us the product gauge structure of particle physics. It is the exact same algebraic constraint, the commutator equaling 0, manifesting in 3 completely different ways. It's kind of beautiful when you think about it. There's a quote from the source material that just perfectly captures our whole journey through this explainer. Conservation and locality are not rules placed on the universe. They are what admissible continuation algebra necessarily looks like from inside. We don't invent physical laws. We don't just happen to live in a lucky universe that happens to like complex numbers and locally conserved energy. We are simply discovering the unavoidable mathematical shadow of independence. I want to leave you with a final provocative thought to chew on as you look at the universe just a little bit differently today. If local conservation, quantum amplitudes, and gauge symmetries all emerge from just ensuring independent things stay independent, what other massive mysteries of reality are simply what admissible algebra looks like from the inside? Thanks so much for joining me on this deep dive. See you next time.